In Lesson 2, Part C, we're going to begin looking at ratios. In previous lessons, you analyzed how quickly Earth's population is growing. Rapid population growth could impact sustainability, that is, Earth's ability to continue to support human life. Objectives for this lesson are that you'll be able to understand that ratios are one way to compare numbers of varying magnitudes. Ratios can be used to make different types of comparisons, and that units should be included in ratios. You'll be able to recognize when it is appropriate to express a ratio as a percentage. You'll be able to calculate ratios of large numbers and estimate ratios of large numbers. In 2011, the population of the United States was approximately 311 million, and the world population was about 7 billion. Write a ratio comparing the U.S. population to the world population as a fraction. Think about how you could simplify the answer to use smaller numbers. So our ratio, if we want to compare the two, a ratio looks like a fraction. We have 311 million compared to 7 billion. The first thing I would do is write this out. 311 million, remember a million, that's going to be 6 zeros, over 7 billion, that's going to be 9 zeros. Oops, I left off one there. There we go. So I have 311 million, and on the bottom in the denominator, I have 7 billion. One of the things we can do is cancel out some of these zeros. Remember, if I take a zero off of both the top and the bottom, that's like dividing them both by 10. I can do it here, here. In fact, what we see is we can take out 6 zeros. So one ratio is to say that the ratio is 311 to 7,000. This is the United States population, and the bottom is the world population. So there's a simplified ratio. We may want to make it even a simpler ratio. If we wanted to round more, we could round this to the nearest million and say, look, we're going to compare 300 million to 7 billion. By simply rounding this to 300 million, we can take off some more of those zeros. So there's 300 million, and then 7 billion. Again, we have 1, 2, 3, 4, 5, 6, 7, 8 zeros here. We can take all of those and take off 1, 2, 3, 4, 5, 6, 7, 8 zeros here. So we can make an even smaller ratio, saying it's about 3 to 70. What does that even mean? Well, it means 3 out of every 70 people in the world are Americans. Since this ratio is a comparison of part of the world population to the total world population, the answer can also be written as a percent. All right, it's very important that you understand when you calculate a percentage, you are always comparing part of something to the whole. In this case, the part we're looking at was the US population, and the whole thing that we're looking at is the world population. The only time it makes sense to do a percentage is when you are doing a part to a whole. There's a couple of approaches that you can use to do this. You can do it like part over whole. This is going to give us a decimal times 100%. So if we go back, let's go back to the 311 over 7,000. $311 divided by 7,000 is probably going to be kind of a messy decimal. When I write it as a decimal, whoops, I get 0.0444. I could keep going, but that's enough on my computer. On my calculator, times 100. So if I multiply that times 100%, we see that the United States is about 4.44% of the world's population. Write a contextual sentence. What does that mean? It means let's put these numbers in some context. The U.S. population is 4.44% of the world's population. Another one you might want to think about is what the percent means. It means per 100. 4.44 people out of every 100 people in the world are Americans. In 2011, the population of China was 1.341 billion. Compare China's 2011 population to the world population with a ratio. Write your answer as a percent and as a fraction, and consider how many decimals to give in your final answer. So we know that in 2011, China's population was 1.341 billion, and the world population was 7 billion. One of the things you'll notice is that the population for China is given with a lot more precision than the world population. We have to assume that this world population has probably been somewhat rounded. But let's write it. So our ratio would be 1.341 billion to 7 billion. Notice this time we don't have to cross out all those zeros because they're both in billions. So that's one way to write the ratio. And that is, of course, the Chinese population to the world population. We might want to round that a little bit. We might want to do something, we could even do something like this. This is about 1.3 to 7. Notice we have a decimal and a fraction in the fraction. If we multiply that by 10, that would mean about 13 people out of every 70 people live in China. Okay. Let's do our percent. If we do a percent, we're going to look at that ratio, 1.341 divided by 7 times 100%. Came out to be about 19.157, but I think that's a little bit more detail than we need, especially when we only know this to be rounded to the nearest billion. So I would probably just say 19%. Compare China's population to the population of the United States. Write a sentence that interprets this ratio in the given context. So let's go back and get our numbers. China had a population of 1.341 billion. So we have 1.341 billion compared to 311 million. We write this out, that's 1,341,000,000. And this, of course, is just 311 million. Notice there's 6 zeros at 6 zeros. We can just reduce that. Now, that's kind of an awkward ratio. We might want to try to round those numbers a little bit. It's probably not going to reduce very well either way. If we do that, let's go ahead and divide. 1341 divided by 311 comes out to be about 4.3 Chinese to Americans. There are 4.3 capital Chinese citizens for every 1 American. Citizen. In other words, the population of China is more than 4 times larger than the population of the United States. In the next activity, you will analyze how these growing populations may be affecting sustainability by studying water footprints. According to the website www.waterfootprint.org, people use lots of water for drinking, cooking, and washing, but even more for producing things such as food, paper, cotton, clothes, etc. The water footprint of an individual, community, or business is defined as the total volume of fresh water that is used to produce the goods and services consumed by the individual or community or produced by the business. So you'll notice these two tables are very similar. The only difference is that in the left-hand chart, the water is expressed in liters. A liter is a little bigger than a quart. And in the right-hand chart, the water is expressed in terms of gallons. I was really surprised when I looked at this because I drink tea. That 1 cup of tea requires 8 gallons of water. And that takes into account all of the water that was used in growing the tea, processing the tea, packaging the tea, everything that goes into it. Even though when you make a cup of tea, you actually only use 1 cup of water from the kitchen faucet. You'll notice things like beef. 1 pound of beef requires 1,857 gallons of water. Beef is one of the things that has a really huge effect on our environment, and the fact that Americans eat so much red meat. I had no idea that it required that much water to grow beef, to grow those cows, but every 1 pound of hamburger meat required 1,857 gallons of water to produce. Okay. The table below gives the population and the water footprints of China, India, and the United States from 1997 to 2001. You can see that China's population at this particular time, was over 1 billion. India's was right at 1 billion, and the United States was at 280 million. The largest consumer of water was in fact India, not China. But I think if we look at the amount of water used per person, the United States uses the most. Complete the contextual sentence. United States had about 280 million people during the period 1997 to 2001. Write a contextual sentence describing the water footprint of the United States using a number-word combination as in question 5. Let's go back and look at question 5. Well, how much water did we use? We used about 696. Now let's look at that. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's billion cubic meters per year. So let's see if we can write that sentence. The USA used about 696 billion cubic meters of water per year from 1997 to 2001. Let me go back and make sure I got the right year, but which years we're talking about is important. Yes, from 1997 to 2001, the U.S. used about 696 billion cubic meters per year. Write the numbers in the table in scientific notation under the numbers written in standard notation. So I want to write this. This would be 1.2. I'm going to keep round to here. Notice, so when I look to the right, 7 is going to make that round up. So 1.26 times 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. I had to move that decimal 3, 6, 9 places. So 10 to the 9th. This will be, let's go here. Oh, that is going to round up. 1.01 times 10. Again, I'm going to move it 3, 6, 9, right behind the 1. For the US, it's going to stay 0, so we're going to have 2.80 times 10. I'm going to move it 3, 6, 7, 8. Definitely smaller, and you can see when we have a smaller exponent, we're smaller by about a factor of 10. Their population is about 10 times greater. Now our water footprint, that will not round up, so that's 8.83 times 10, 3, 6, 9, 10, 11. This will be, that's not going to go up, so 9.87 times 10. Again, 3, 6, 9, 10, 11. And then for the United States, it's going to be 6.96, 3, 6, 9, 10, 11. Notice when we look at the size, the amount of water we use is not that much different than China and India, but our population is significantly smaller. You can see we only have 10 to the 8th. These are on the order of 10 to the 9th. Okay, part D, analyzing water footprints. In the previous activity, you read about water footprints. The water footprint of an individual community or business is defined as the total volume of fresh water that is used to produce the goods and services consumed by the individual or community or produced by the business. Okay, this table shows us the population and water footprints for China, India, and the United States from 1997 to 2001. Write the numbers in the table in scientific notation under the numbers written in standard form. All right, you just did that, but it'll be good practice to do it again. I'm going to do 1.2, and I have to decide, is it 5 or 6? I look at that, it's going to be 6 times 10, and then I move the decimal from right here, the end of the number, 3, 6, 9 places. Similarly, this was 1.01, 3, 6, 9 places. And then our population, 2.80 times 3, 6, 7, 8. So there's our smaller population. This is 8.83 times 10 to the 11th. That's 3, 6, 9, 10, 11. 9.87 times 10 to the 11th. And 6.96 times 10 to the 11th. Okay, what are our objectives? We want to understand that large numbers can be represented in many forms. Water can be measured and compared as a water footprint for a country, as a whole, or as a per capita measure. Per capita means per individual or per citizen. You will be able to write and interpret numbers in scientific notation and perform operations with scientific notation using a calculator. Notice the countries listed in the table are ranked from the highest to lowest population. Using the data in the table total water footprint column. Rank the countries from highest to lowest according to their total water footprint. Let's see. Well, if I'm ranking them for their water footprint, I would say India uses the most. 1, 2, 3. This is the water footprint. Now, that's just their total water. It's not per capita. How much water did the average person use in the United States? Add a fourth column to your table to hold your answer and be prepared to justify your response. Okay, let's do a total amount of water per person. So we're going to do total water footprint per person. And that's going to be in cubic meters per year. I just have to take the water and divide it by the number of people. So I'm going to take this 8.83 times 10 to the 11th, and I'm going to divide it by 1.26 times 10 to the 9th. I'm going to do it in my calculator. I want you to be sure when you're dividing that you either set it up so that you have a division bar, or you can use parentheses to make sure. If you don't, you're possibly going to get a wrong answer. Highly, highly recommend parentheses. So 8.83 times 10 to the 11th. I also hope that you've got your calculator out and that you're going to work through this with me. Divided by 1.26 times 10 to the 9th. This came out to be, on my calculator, 700.79. You get lots of places, but let's think about it. Let's just round to the nearest whole number. There's the whole number. This is 701. If you need to pause this so that you can do your own calculations, I think that would be a great idea. And then you can see if your numbers are similar to mine. So I'm going to take this. Again, I'm going to divide it by the population. .87 times 10 to the 11th power divided by 1.01 times 10 to the 9th power. This in my calculator said 977.22. Got some more stuff, but remember, we're going to round to the whole number. So this is just 977. And then finally, let's do the United States. We're going to take all of this water, divide it by the number of citizens. .96 times 10 to the 11th divided by 2.80 times 10 to the 8th. Oh my goodness, this came out to be 2,485.714. So if I round this to the whole number, that's going to be 2,486. Notice how much larger our water footprint is. That really represents that Americans have a much more affluent lifestyle. Okay, we added our fourth column. You can see how much more we use. I'm going to write those down. I believe China was 701, India, USA. Let's go back and look. 977 and 2486. It certainly can justify how we got our answers. That's very clear. We should probably give a lot of thought about whether or not this is fair that the United States does use so much of the world's fresh water. The answer to the previous question is called the water footprint per capita. Place this label in the fourth column, including units, and then compute the water footprint per capita for China and India. We've already done that. Rank the countries from the highest to the lowest footprint per person. When we look at per person, the highest is the US, then India, then China. Let's go back and look at how we tabled our column. I put total water footprint per person. I could have, and let's change it. Whoops. We could have said per capita. It means the same thing. Total water footprint per person is the total water footprint per capita. The units were the same, cubic meters per year. During the same period of time, how many times larger was the population of China compared to the population of the United States? Let me compare. The average person in the United States used how many times more water than the average person in China? Okay, the average person in the United States, what did we write them down? 2486. The average person in China only used 701. So let's compare that. We'll compare using a ratio, 2486, and that is in the US per capita. $701, and that was in China per capita. 2486 divided by 701 comes out to be 3.5 if we round it. We could go a little far, but 3.5 is good enough. So the average US citizen uses 3.5 times more water per year than the average Chinese citizen. During the same period of time, how many times larger was the population of China compared with the population of the United States? Well, the population of China at that time, let's go back and pick up those numbers, was 1.26 times 10 to the 9th and 280 times 10 to the 8th. 1.26 times 10 to the 9th. This is China. That's their population. This is the USA's population. If I do that division, and again, I want to be sure when I'm putting things in my calculator that I do all of this divided by all of this. 1.26 times 10 to the 9th divided by 2.80 times 10 to the 8th. And that came out to be 4.5. I think we found that earlier. Write your answer in a sentence. The population of China was 4.5 times greater than the population of the United States. From 1997 to 2001. That populations might not have had that exact same ratio if we were looking at a different time period, so we want to be specific. Write a couple of sentences that relate the information from the previous two questions and what these facts might mean in terms of sustainability. Let's think. I believe we discovered that we use per capita. Where's our per capita? 2486 compared to 701. That the U.S. citizen uses 3.5 times more water than the average Chinese citizen. Well, I guess the one good thing is it would be much worse since China is so large if they used more than we did per person. But it's not, doesn't seem very equitable. We could write something that although the U.S. population is less than 1/4 of China's. Now remember, China had 4.5 citizens for every 1 American, so our population is less than 1/4. The average U.S. citizen uses 3.5 times more water. I don't know what that means in terms of sustainability, other than the fact that the U.S. will need to make changes. U.S. should probably adjust their water consumption. And it's probably not the water so much you're using at your home, but what's using to manufacture things that are in your home. I said it does. They should probably, the U.S. probably should decrease, I'm going to say, their consumption. I misspelled consumption, so let's fix that. How much water they're consuming. To increase sustainability. These would be good discussions if we were in the classroom. Unfortunately, I'm kind of discussing with myself, but we can talk about some of these ideas in our Tuesday night meetings.